Assalamu alaikum. I am Muhammad Jahangir Alam, lecturer in physics from Milestone College. I welcome you all in my online class. First of all, thanks to Almighty that He has given me the ability to take this class. We are still okay and carrying on our regular activities in this worldwide situation of COVID-19. So thanks to Almighty again. Dear students, I hope all of you are well by the mercy of Almighty. Right. Today we are going to discuss some multiple choice type question or MCQ question from our current electricity chapter, and I hope this will help you for your upcoming exam. Right, dear students, the MCQ type question that you have to face in your exam are like this type. Here are three questions. In the first question, there is a circuit diagram, and the circuit they showed that a electric current denoted by I is splitted in this point, and there is a galvanometer and a shunt is connected parallel with the galvanometer. The main current is split here, and 0.2 ampere is passes through galvanometer, and the remaining 2 ampere passes through the shunt. So here question is, what is I? That is, we have to calculate the value of the main current I. So I think it is clear to all that the main current I, which is resolved in this point and split it in two parts. One is 0.2 ampere and the current passes through the shunt is 2 ampere. So the main current will be calculated by the summation of this value and this value, and we know I is equal to Ig plus Is. Here Ig means current through galvanometer 0.2 ampere plus Is means current through shunt, which is 2 ampere, and our final result will be 2.2 ampere. Right? I hope you got it. This is the answer for our first question. Asa. In second question, there is also a circuit diagram. Here this is a source of electric current, that is EMF of this source is 20 volt. The current due to the source is I, which passes through a resistance 4 ohm and which is splitted into two parts in the parallel combination. The two resistance 6 ohm and 3 ohm which are connected in parallel, then a 4 ohm resistance is connected. So from this figure we have to calculate the value of I, that is the main current. To calculate main current, first we have to calculate the equivalent resistance of this combination. Dear students, here 6 ohm and 3 ohm are in connected parallel combination. So equivalent resistance for this part, that is the equivalent resistance of the parallel combination, if denoted by Rp, we know Rp is equal to 1 by 6 plus 1 by 3 and inverse value of the summation of the inverse value of the individual resistance, right? And after the calculation we will get the LCM will be 6, 1 plus 2 3, 3 by 6 inverse, and the final result will be 2 ohm, that is the equivalent resistance of this part will be 2 ohm, and the final resistance or total resistance of the circuit will be, if denoted by Rs, Rs is equal to 4 ohm, that is this 4 ohm plus the equivalent resistance of this combination is 2 ohm and lastly 4 ohm, and the final value will be 10 ohm. So total resistance of this circuit is 10 ohm. Here the electromotive force E of the circuit is 20 volt, right? So we have to calculate the value of current. We know I is equal to E divided by Rs, right? So using the value of E and R, the value of E is 20 volt and Rs means 10 ohm. So final calculation will be 2 and the unit is ampere, right? So this is the final result for our question 2. Okay. Now we are going to solve our third question. In third question, they said that what amount of current passes through a bulb of 220 volt 44 watt. Here the information about the bulb is the bulb is connected across a source whose potential difference is 220 volt and what means power of the bulb is 44 watt. So we have to calculate the current, right? Here students, here the potential difference V is equal to 220 volt. This is the potential difference across the bulb. Power of the bulb P is equal to 44 watt. We have to calculate the current I. We know P is equal to VI, right? So from this expression we can write I is equal to P divided by V. Okay, so value of P is 44 watt and value of V is 220 volt, and after the calculation we will get to 0.2 and the unit of I will be ampere, right? This is the final result for our question 3, right? Dear students, our next questions are in question 4 there is also a circuit diagram. Two resistance 4 ohm and 4 ohm are connected in parallel, then a resistance of 3 ohm are connected with this combination is series, and the whole circuit is connected with a source of 3 volt. So the question is, what is the current in the circuit? We have to calculate the current in the circuit, right? So to calculate the current in the circuit, first we have to calculate the equivalent resistance of the circuit, and to do that first we have to calculate the equivalent resistance of this combination, that is of parallel combination. Here 4 ohm and 4 ohm are connected in parallel. So equivalent resistance for the parallel combination if denoted by Rp is equal to 1 by 4 plus 1 by 4 inverse equal to 2 by 4 inverse, that is 2 ohm. That is the equivalent resistance of this combination is 2 ohm, and 3 ohm is also connected in series with this parallel combination. So total resistance Rs is equal to first 2 ohm, that is equivalent resistance of this combination, plus 3 ohm, and that is 5 ohm. So total resistance of this circuit is 5 ohm. Electromotive force of the cell E is equal to 3 volt. So the current I is equal to E divided by Rs. Here E is 3 volt, R is 5 ohm, and after the calculation we will get 0.6 ampere. The unit of current is ampere. So this is the result of question 4, right? Now we are going to solve question number 5. In question number 5, they said that resistance of a coil at 0 degree Celsius is 2 ohm. Here the resistance of a coil at 0 degree Celsius is 2 ohm and temperature coefficient alpha, which is denoted by alpha, is 0.004 per degree Celsius. What is the resistance of the coil at 100 degree Celsius, right? To solve this, first we have to write the resistance of the coil at 0 degree Celsius, which is denoted by R naught, is equal to 2 ohm, right? And temperature coefficient of resistance alpha, alpha is equal to 0.004 per degree Celsius. So we have to calculate the resistance of the wire at 100 degree Celsius. So R, first we can write the temperature of the wire, theta is equal to 100 degree Celsius. So we have to calculate R theta is equal to what? We know R theta is equal to R naught into 1 plus alpha theta, right? Here students, the value of R naught is 2 ohm multiplied by 1 plus alpha, alpha is equal to 0.004 multiplied by theta, theta means 100 degree Celsius. Okay, so after the calculation 2 ohm multiplied by, we will get 1 plus 0.4 and final calculation 1.4 multiplied by 2, that means 2.8 ohm. So this is the final result for our question 5. Okay, finally you are going to solve our last question. Here in the circuit diagram they show a electric source or source of electric current is 9 volt. Main current I is originated from the source which passes through a resistance of 20 ohm. Then it is splitted in this point into two branches. One part is passes through the resistance 12 ohm and the value of the current is denoted by I2, and the remaining part of the current passes through 10 ohm resistance which is denoted by I1. Then it merges and back to the negative point of the source. So here we have to calculate the value of I2, that is the branch current passing through this 12 ohm resistance. To solve this, we have to first calculate the equivalent resistance of the circuit. In the circuit, these 2 ohm are connected in parallel and 20 ohm is connected in series with the parallel combination. So first we have to calculate the parallel combination. If the equivalent resistance of the parallel combination is denoted by Rp, then Rp is equal to 1 by 12 plus 1 by 10 whose inverse value, and the result will be 65, 6, 11 inverse value, and after the calculation we will get 5.454 ohm. That is the equivalent resistance of this part of this parallel combination is 5.454, and a resistance of 20 ohm is connected with this combination. Here the total resistance of the circuit, if denoted by Rs, Rs is equal to 20 ohm plus 5.454 ohm, that is 25.454 ohm. This is the equivalent resistance of this circuit. Now we have to calculate main current, then we will be able to the partial current. Here E, that is electromotive force of the source, is 9 volt. So main current I is equal to E divided by RS. Here the value of E is 9 volt and RS is 25.454 ohm, right? After the calculation we will get 0.353 ampere. This is the main current. Now we have to calculate the potential difference between the 2 points, and this will help us to calculate the partial current, that is I2. Okay, so now we are going to calculate the potential difference across the parallel combination. Potential difference across the parallel combination is denoted by V. V is equal to I. Main current I is passing through, is entering in this combination I, multiplied by the equivalent resistance of the combination, which is denoted by Rp. Okay, the value of I is 0.353 multiplied by Rp, which is 5.454 ohm, right? 1.928 volt, right? So potential difference between this point and this point is 1.928 volt. Now we can calculate the current or branch current passing through this resistance. So the current, which is denoted by I2 is equal to V divided by 12 ohm, right? The value of V means 1.928 volt divided by 12 ohm, 0.16 ampere, right? This is our final value for question 6, that is a current passing through the 12 ohm resistance is 0.1. In question 7 they said that if 20 coulomb charges passes through a resistance of 5 ohm per minute, then what will be the potential difference across the resistance? We have to calculate the potential difference across the resistance. We know the potential difference across a wire or resistance can be calculated by the product of the current passing through it and the resistance of the wire. Here the resistance of the wire is 5 ohm. Resistance of the wire is 5 ohm, but current through the wire is not given. So first we have to calculate the current through the wire, then we will calculate the potential difference, right? Dear students, to calculate current, here the charge which passes through the conductor is given. So charge is denoted by Q. Q is equal to 720 coulomb, and required time is per minute, that is 720 coulomb charge passes through the wire in 1 minute. So time T is equal to 1 minute, that is 60 seconds. So electric current I is equal to Q divided by T. Q means 720 coulomb divided by 60, and the final result will be, if we cancel out 0, then it will be 12 ampere, right? Now resistance of the wire is 5 ohm. Okay, resistance R is equal to 5 ohm. So we have to calculate now the potential difference. We know potential difference V is equal to IR, right? So using the value of I and R, we will get I means 12 ampere and R means 5 ohm. So the final result will be 60 volt. So this is our final result for question 7. Now we are going to solve our last question. Length of a copper wire of 9 ohm is made 3 times by stretching it. What will be the final resistance? We know resistance of a wire depends on its length and area of cross section. If we made the length of the wire 3 times, that is length will be increased and area of cross section at the same time area of cross section will be decreased. When we stretch a wire, when length will increase, then it will thin, that is area of cross section will decrease. So there are two changes in this phenomena. First, length will be increased and area of cross section will be decreased. So what will be the final resistance? Here the initial resistance R1 is equal to 9 ohm, right? We don't know what is the initial length. If initial length is L1, then final length L2 is equal to 3 L1, right? They told us that the length made 3 times by stretching it. At the same time, if initial area of cross section if A1, then final area of cross section A2 is equal to A1 divided by 3, that is area will be decreased. So we have to calculate the final resistance. R2 is equal to what? Dear students, we know resistance of a wire is denoted by R is equal to rho into L by A. This is our base formula. If we use the formula for the first situation, that is R1 is equal to rho into L1 by A1, and for the second situation R2 is equal to rho into L2 by A2. Now we have to divide equation 2 by 1. We can write the equation number 1 and this by 2. So we have to divide equation 2 by 1. Dividing 2 by 1. Okay. So we will get R2 by R1 is equal to rho, that means a specific resistance from the both expression will be cancelled out. We will get L2 by A2 multiplied by A1 by L1, and after the using the value of L2 and A1, L2 means 3 L1 or A2 means A1 by 3 multiplied by A1 by L1. Dear student, after the simplification we will get 9. So therefore R2 is equal to ki hobe 9 multiplied by R1, that is 9 R1. R1 means 9 ohm, that is 81 ohm. So this is the final resistance of the wire, right? I hope you got the solution and you have to practice this type of question for your exam. Okay, so thank you very much being with me. May Allah bless all of you. Assalamu alaikum.